is solving trig equations. Okay, so you have to have your unit circle in order to do this. Okay, so example number 1, I'm just going to show you how to do this using examples. Okay, your first step in solving a trig equation is to isolate your trig piece. Okay, so for question number 1, I've got a cosine. I need to get rid of that 1/3. So how would I get rid of a 1/3? Okay, multiply, and it's actually negative, so it's actually -3. Okay, now notice the variable that we're trying to find is theta. Okay, do you remember what theta is usually representing? Okay, it is an x, but more specifically, it's representing an angle. Okay, so we're trying to find angles. Yes.
Times the -3 over to the other side.
Oh, yeah. Sorry, it's 0, my bad. Thank you. Thank you, team. Good job. So we should have a 0 over there, my bad. What? I called him Tim? No, I didn't. That's his new name. Alright. Okay, so at this point, this is where I grab my unit circle, and I'm using those 3 little, no, I guess there's 6 of them. Okay, so we have the sine is equal to the y, the cosine is equal to the x, all that stuff over there. Okay, so since I'm working with cosine, the cosine is equal to x. So what I'm doing is I'm looking on the unit circle on the ordered pairs and trying to find where the x value is 0. So where do you see an x value of 0? There should be 2 places. Okay, so 90 degrees and what'd you say? 270. Now do you see up here at the top of this, so it says write your angles between 0 and 2 pi? What is that telling me? We need it in radians. So we're going to say instead of 90 degrees, we're going to call that pi over 2. And 270 is the same as 3 pi over 2. Okay, so 2 solutions to that one equation. Okay, let's try another one. I'm actually going to skip down to, let's try number 3 first, and then I'll go back to number 2. Okay, so you tell me, what do I do first for question number 3? Okay, good. So I'm going to start by dividing by -8. Okay, so I end up with the cosine of theta is equal to what? So we got a negative over negative, those cancel. We end up with a square root of 3 over 2. Perfect. Right? Everybody get there? Okay. Well, the negative over negative turns to the positive, and then the 4/8 reduces to 1. Yeah, it would just be a negative, yeah. Okay, so now I grab my unit circle again. I'm working with cosine again. So cosine is referencing which variable on my ordered pair. Okay, so I'm looking at the x values of the ordered pairs, and where do you see an x value that is a square root of 3 over 2? There should be 2 spots. 2 pi over 3 and? Is that right?
No, pi over 6.
I just assumed John was
Pi over 6 and 11.
Pi over 6? I'm never going to listen to you again, John. Alright. Are we good there?
Yes.
Okay. Let's try a tougher situation. Okay, let's work with a cotangent. Alright, so we are going to start this off exactly the same. We're going to isolate our trig piece. So what would you do first? Divide by -3. So if I divide by -3, what is 3 square root of 3 divided by 3? Good. So we get a negative square root of 3, and that's equal to the cotangent of theta.
So when x over y.
So, okay, hold on, let me explain. Slow down. On your unit circle, it says the cotangent is what over what?
X over y.
X over y. Okay, so that means that the x over the y is equal to the negative square root of 3. Okay, now what has happened is that the fraction from the ordered pair has been reduced into a negative square root of 3. Okay, they're giving you this reduced answer. So we have to undo it and figure out what angle is going to reduce to a negative square root of 3. Okay, so let's kind of undo this and say, okay, well, a square root of 3 is the same as a square root of 3 over 1. Okay, now if you look at your unit circle and all the spots where you see a square root of 3 over 1, what do the ordered pairs look like? Okay, so you have situations where if there's a square root of 3 involved, it's a square root of 3 over 2, and then the other piece is 1/2. You see what I'm saying? Yes. So what I know here is that we're either using like 1/2 is going to be the x, and the square root of 3 over 2 is going to be the y, or it's the other way around, where my x is square root of 3 over 2, and the y is 1/2. Okay, ignoring the negative for a second. Okay, we'll talk about the negative last. Okay, so if I have x over y, how could the x over y simplify so that the radical of the 3 is left? Okay, if you don't know, let's just pick one. Okay, you want to pick the bottom one? All right, let's try. So John says the bottom one. I listened to him last night and they got me in trouble. So if I do x over y on the bottom one, what is it going to go? Okay, so what's my x value? Square root of 3 over 2. So this is going to be x over y. Sorry, I wrote that really close together. So my x is square root of 3 over 2. My y is 1/2. We all know that if you divide by a fraction, that's the same as multiplying by the reciprocal. So that's going to be a square root of 3 over 2 times 2 over 1. What happens here? Okay, what's left over? Square root of 3. So was John right?
Yes.
Yes, John was right. Okay, so we are looking for this situation where the x value is a square root of 3 over 2 and the y is 1/2. But in our equation, we're working with a negative. So that means that one of them has to be negative. Okay, so there should be two places on your unit circle where the x is a positive square root of 3 over 2 and the y is a negative 1/2. And the opposite version of that would be a positive square root of 3 over, no, I said that wrong. A negative square root of 3 over 2 and the y is the positive 1/2. 5 pi over 6. Which one is that?
Yeah.
So let's do the square root of 3 over 2 and a negative 1/2.
11 pi over 6.
So let's do that. Okay, so that was 11 pi over 6.
And then the negative square root of 3 over 2.
5 pi over 6. Yeah, so the 2 points that we're looking for is we need the square root of 3 over 2 and a negative 1/2. And then the negative square root of 3 over 2 and a positive 1/2. Okay, how do we do there? Okay, the tangents and the cotangents are the ones that are the hardest because those fractions have been reduced. But once you kind of figure out the pattern, they get a lot easier. Okay, can we do one more?
Yeah.
Let's do one more. Let's see if I can find a hard one. Like, ooh, that one looks intense. Not that one, but this one. Ooh, let's do this one. Ooh, yeah, that's a good one. 12. Yeah, let's do 12. It's actually not too bad. Hold on, I think I don't want to do 12. Actually, let's do 12. That's fine. We're fine. It's fine. Okay, so now this one is a little bit different than the last three that I did. Okay, and the difference between them is the fact that I have a trig function of stuff and not just of theta. You see what I mean? I got this whole quantity that I have to work with. Okay? That's not a thing you can distribute a cotangent. So what I'm going to do is I'm going to solve for the cotangent. I'm going to figure out what the parenthesis pieces equal to, and then I'll work with that last. Okay? So, start by isolating the cotangent. What's your very first step? Plus 1. Alright, so -1 plus 1 is 0. And so we have 0 equaling the cotangent of theta plus pi over 2. The ceiling. From the classroom above us and the weight that is moving around. Super fun. Alright, so now's the part where I grab my unit circle. Okay, and I'm going with cotangent. Okay, so cotangent by definition is what over what? X over y. So I need for the x over y to equal 0. So, how can x over y equal 0?
When it's
Okay, if
at
it's 0 over 1, meaning the x value must be 0. So where on your unit circle do you see an x value of 0? There should be 2 places. What'd you say? Pi over 2 and 3 pi over 2. Okay, so do you remember how I have this cotangent of some stuff?
is that 0 or theta plus?
That's a theta. Okay, this piece right here is the same as this. So all I'm doing is I'm dropping that down. The cotangent of the stuff is now equal to pi over 2 and 3 pi over 2. Okay, so now my last step is now isolating my theta. What's my last step here?
Okay, so the bottom one is theta, or
This is a theta. Okay, so how would you isolate the theta?
subtract?
Subtract 3 pi over 2. Okay, so I'm going to subtract 3 pi over 2 from both of those two values that I just got.
Wait,
Okay, so theta is going to equal, so I have pi over 2 minus 3 pi over 2. So what would that be? What? Okay, yeah, you get negative 2 pi over 2. The 2's cancel, so you get negative pi. Okay, and what's 3 pi over 2 minus 3 pi over 2? Good. That was good. And that's a 0 that time. So those are your two solutions to that equation. How do we do? We got that?
yeah, I think I got this.
Ready for the worksheet?
Oh yeah, it's the same. It's more ready.